So, LegacyWare, what is it? That's legacy software, which is becoming an increasing problem, and there is no methodology to know what happens. Legacy software, no one is talking too loudly about it, but the problem is growing, and is growing especially with the internet, because now not only because the machines are faster, you can write more and more code, no one controls it. Exactly, and interconnections make that systems are more and more complicated and cannot be stopped, okay? And big companies, what they do, they are not able to rebuild their information system from scratch. They make it grow, okay? They deprecate some part of it, but just like a city which cannot be built from scratch, okay? They're decommissioning some parts, making some others grow, but no one knows exactly what happens in a big information system in a bank. I think you will agree. So what can we do when, as contractors or consultants, we have to work on a big piece of software which is constantly running? Okay, what can we do? Documentation, static analysis tools. We can read the code, we can use models, we can use tools for reverse engineering the code. What happens, in fact? Okay, methodologies, some of them are 30 years old or 40 years old. No one heard about them, which means that they simply did not work. Reverse engineering tools are able to work on static code, but real application, it's not static code. It's tons of pieces of static code running, but the behavior is not predictable. The systems are always changing. It's very difficult to have a static description of a system. No one knows exactly what happens, and there is no model to describe what a piece of software is doing. There is no abstract model, of course. So it's extremely sad, but what we would need self-updated map of IT systems. We would be happy if any piece of software, a process, a file, a database, could constantly tell what it is doing and what it is, what it contains, what it's pointing to. Okay, Tim Berners-Lee, the creator of the World Wide Web, said, "I have a dream for the web in which computers become capable of analyzing all the data on the web, that is, analyzing themselves and their connection with other computers." This is what Semantic Web is doing, okay? That is, as opposed to the traditional way of documenting software, that is with static documents, which are always out of date when they are published, okay? We need the machines to tell themselves what they are doing, okay? But we have a problem, is that at least we need a formalization of this information. There are two models which can help us, okay? A common information model is used by Windows to describe IT resources. It can be our ontology. And RDF is here to articulate, to link the data described by a common information model. Okay, now let's go into the details. What is SIM? Maybe you heard about WMI? WMI.
Drivers on Windows that are WMI something, I don't know.
Yes, on any Windows machine since Windows XP, there is a subsystem, Windows Management Instrumentation, which allows to have dynamic information about any resource of the operating system with a command line tool, WMIC, okay? So that's exactly what we want on any Windows machine, which is a major operating system. We have a way to describe all the data which are contained in this machine, okay? And it describes classes just as a process here, a process which has a name, a creation date, priority, blah, blah, blah. And this ontology exists also on Linux, okay, because it's an industrial standard. which is called WBEM, okay, and it's standardized by DMTF. Okay, so we have a model, an abstract model to describe any IT resource. Okay, and why is it important? Because when we want to understand a legacy system, we need to describe what are the components of this legacy system. We can't simply say a file or a database. No, we need a formalization. Otherwise, we cannot do any automatic data processing. Okay, so we have this model. It's called SIM, and it's implemented on any Windows machine. It's mandatory, okay, and on any Linux machine if you install WBEM. That's good. Or OpenLMI for Red Hat, for example, which is a major Linux distribution. So we are safe. Now we would like to link the data with themselves, okay, with each other, okay, to link them the way we want to reflect what a legacy application is doing. Something exists, okay, it's RDF. You know much better than me what RDF is doing. Okay. RDF provides a semantic model, the grammar linking IT resources described by SIM. Okay. Now we have an abstract model which allows to link heterogeneous data describing a legacy application. Okay. For the moment, it's very boring, very abstract. We will see what it's made for. What Survol is doing. I show you a quick image. Survol, it's a graphic interface which allows to visualize IT resources, processes, tables, linkable symbol, machine. It's a graphic interface, okay? How is it updated? It's updated by simply reading data on the fly and displaying them, okay? It displays this data with which model? Well, CIM process, CIM data file, SIM, okay? So you might say that it's a graphic interface to WMI, okay, because that's the first most common implementation, okay? How can it be enriched? Very easily with Python, okay? It's a graphic interface. It's not only a graphic interface because it can render this kind of data in HTML, SVG, JSON, RDF. As well. Why RDF? Because internally it stores its data with RDF, because RDF can aggregate data coming from many heterogeneous resources. Why heterogeneous? We'll see why. It has many toolbox scripts which interrogate a running machine. Why these scripts? Why heterogeneous data sources? When you have to work on a legacy software as a consultant, as a contractor, you have no idea of what this system is doing. You might get some information from a documentation, you might interrogate the network, you might see the list of processes, you might see a list, some directories and subdirectories, you might query a database because you've been told that this process interrogates a database. So you will have some very heterogeneous data coming from the sysadmin, the DB admin, a colleague who is leaving, an old piece of documentation, a lot of heterogeneous data, okay? How can you link this heterogeneous data to have the big picture of your application? Well, they have to be based on the same formalization, CIM, okay, makes sense, okay, because we are talking about IT objects. And how can you link them? Well, RDF, which can link heterogeneous data, okay? a table connected to a process which is running a binary, and this binary use a DLL, okay? And this DLL connects to a remote machine, heterogeneous data, objects linked by properties. We have the RDF triples, okay? And it's very easy to enrich this data set because RDF is made for that, okay? And if you add more data, you don't break what you already have. And you can have different islands of data which do not communicate yet, okay? But you know that if you want to have the big picture of your legacy application, you will investigate a table and a database. So, which kind of data we can provide? We are an experimented contractor working on an application. We will see the list of sockets, IT resources, list of processes, shared libraries used by an application, okay? Does it use a DLL of this and that, okay? Nmap to scan the network, to see if, for example, there might be a SQL server on this network. If there is a SQL server, it means that maybe there's an application which is connected to this SQL server. We can see it with Nmap. It's a hacker tool. It allows to ping a machine, a network, and see what's connected on it. Ping strace, for example, to see all the functions calls made by and the system calls made by a program, to see, for example, which files it's accessing, which sockets. Ltrace, GDBs, there are tons of them. And now, instead of typing very cryptic command lines, okay, you just need to click on an icon, which will run a small Python script, which will wrap one of these commands, and the result will be expressed in the CIM terminology, and it will return a set of triples, a set of relations expressed with RDF, okay? So we did not invent anything yet. We're just using plain old tools. PS is maybe 30 years old. CIM is 20 years old, okay? As old as Windows XP, okay? And RDF is younger. So, what can we do on a local machine, okay? We can see, for example, process tree. Let's do it quickly. Maybe that's not the best moment, but we can... No, it doesn't want to react immediately. We will see that later, okay. We can see on the local machine the installed software, the COM components. You will see that for real, okay? But that's only the beginning, because seeing what happens on a local machine, it's a bit easy. But as an example, PyCharm, maybe you know PyCharm, it's a development environment in Python, okay? Basically, it's a big Java process, okay? So let's see. It's displayed with D3, which is a JavaScript library, open source library. So let's see what it displays as a process called PyCharm. Haha, size of the virtual.
To do the boxes and arrows?
Yes. When it's displayed as in JavaScript. Okay, we see a couple of sockets here. We see the executable. Okay, we see the user. Okay, other sockets here. We see the machine. We see the directory which contains the executable, and we see the process, okay, with some information, JetBrains, as expected, okay. That's a very simple example. Let's see another one. On a Linux machine, an Oracle process, we see that the standard database installed by Oracle, nothing complicated, okay? We see the user, it's hosted by Apache, okay? A process, another process, you see, it's not on the same platform This is a Windows machine. It's kind of green box, okay? Same green box, okay? It's a process, okay? Here we see that this is a session Oracle, okay? With some parameters. You know Scott Tiger, you know that the standard Oracle user for demonstration. It was so long time ago, okay? Here you see the process with Oracle PID, okay? And, well, no terminal, of course, okay? This is a local example, but on another platform, okay? And we've said that we can output data. By the way, you will see if, yeah. This is a D3 output in JavaScript, but this one is an SVG output, which is very similar, okay, but the routing is different, and it's much more convenient when you want to print something, okay? The routing is different. It's done on the server, whereas the display here is done on the client, okay? That's the detail, okay? There are other output possible. Here we see another kind of information, the NumPy Python package. The output is printed in HTML, and it gives some output, just like the dependencies. Yes, these are the dependencies, okay? You get this information just by clicking, okay? Just by clicking. Now, this is a bit more interesting, still in D3. We see the shared memory. You know what shared memory is. Basically, it's a piece of memory which is accessible, linked by, connected to by several processes. And of course, it's extremely important when you want to understand if and why and how several processes are talking to each other, okay? Because there are no tools at the moment to analyze what happens in a piece of shared memory when several processes are reading and writing into it, okay? No tools. Okay? So what happens still by right-clicking shared memory segments? What do you have? You have a big network of all the interesting shared memory segments and the processes connected to it, okay? For example, kernel-base.dll, which is mapped, and a couple of processes are connected to it. Tortoise, for example, Tortoise, you know, Git merge, you know, it's a software software management program. You see all of this process, Python, PyCharm, blah, 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 and they are connected to a lot of shared memory segments. And it helps. Of course, like I displayed all of them together just to impress the public, but you can delete the one you're not interested by and see if, for example, Mobaxterm is using this one. It might be interesting, okay? Or Firefox is using another one in this direction, okay? Windows Explorer is using that. What is it doing? I don't know. But at least it gives a hint of what a process is doing, okay? What else? Well, PowerPoint. Interesting. Okay, and you have a lot of scripts like that, and you can add more if you want. Now, this was for a local machine. Now, you can do that on two machines, because two machines might talk to each other with sockets, okay? And you might say, okay, I start my Survol agent on one machine and another, and let's see what happens, okay? And the interesting thing is that you can drag and drop the URIs, the links, okay, the nice links in JavaScript, so that you will see the connection of two applications in the same window. What happens? Okay, we'll see that with two examples. Here, these are, you remember we have displayed all the, no, it was here. Here, this is a display on each machine of all the sockets, all the, not the local socket, all the sockets created on a machine, okay? We have two machines here, okay? This one, a desktop, it's a Windows machine, okay? This one, by the way. And here we have another machine, here, which is a Linux server, okay? If we drag and drop the set of sockets and connected processes on the same browser, Survol will connect the objects which are seen from two different agents. Here, what do we see? We see the same socket, the same socket seen from this Windows machine and this Linux box. We see where is the connection. Okay? Basically, it means that if you have several machines that you suspect are talking to each other, you just need to display their resources, drag and drop them into the same browser session. The identical objects will be detected by Survol, okay, in a very simple way, and they will be linked like that. And you see the interaction is absolutely obvious. The way it's done is very simple. It's not rocket science at all. Okay, and here we see, in fact, I had a telnet session from this machine to Linux box. So nothing really critical, but it was seen immediately. What else can we do here? This is a remote Oracle connection. It's very pedantic to say that I was doing a SQL Plus from this box to a remote to my server. We see SQL Plus server. You know what SQL Plus is? It's Oracle SQL interrogation program.
Is it a command line?
Yeah, basically you connect to SQL Plus and you can type select blah 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 from this table, and it's a very traditional tool. And if you drag and drop the processes from these two machines, you will see that it sees the same process from the two machines. Okay? And you can see immediately that the Linux box is connected to a Windows process. Okay? And this Windows process might be an application. It might be connected to something else on the machine, on the Windows machine. So from one step to the other, you can have the big picture. Okay? And what's nice is that it can display data in HTML, SVG, but as well in RDF. It's a very primitive form of RDF, to be honest. I did not explore that yet because I'm not a specialist. What it shows is that it's doable. It can generate its data into RDF in a very primitive way, which can easily become nicer and more standard. Okay, so please be nice and patient with that. It's certainly not professional RDF, but the data is there. Okay, and the formatting is there because it simply uses RDF-lib internally to store its data, and this is generated just by using the appropriate method in RDF-lib, which nicely generates that, which can be seen, and it can be easily become better.
So
it depends.
Pages is the official RDF specification?
I don't know. I'm not a specialist. It's a very convenient data model for this, extremely convenient, but maybe I know 2% of RDF.
Yeah. So there are libraries to write.
Yeah. It's possible to do fantastic things that I nearly not explored yet. So that's it. We will make a living demonstration if you want to. But the future direction is to explore, to use RDF data, okay, for storage and inference. Add new scripts, because it's very easy to create a specific script to extract a specific set of data. Another source of exploration, which is very specific to have a better understanding of a legacy application, is to apply process mining technology, which is to extract basically the business objects from log files. Okay. Jupyter Notebook integrations, it's already started. It's not very difficult, and other technical stuff.
So when you call triples?
Triples, it's a formalization of data which is the subject, the predicate, and the object.
Ah, okay.
Nothing more. It's very simple, very flexible. Okay. So if you want, I can. Yes, I can quickly show you how it works. Okay, this is a tree. This is a local machine that we are talking about. Okay, I can show you a couple of things. For example, the installed Python package. It's a slow machine, to be honest. Okay. Yes, these are all the Python packages. What can we do with that? We can. Okay, so we always have the same ID for each package, for each object. You can right-click and you have a list of scripts which can be applied. Okay, there's not a lot of stuff. But again, it took 20 lines of data. So here it shows a file of the package, the main file. Which, because it's a file, we can ask more information, typical of a file. Okay, that's a directory. We can see its content. Yips, files in directory. Yeah, okay, and so on and so on and so on. Okay, what kind of information we can see? The Java world as well. Do we have Java processors here? I'm not a Java specialist, far from that, even if it's a fantastic language, but that's something I would like to explore. Oops, it's not nice. It's not a problem at all because, yep. Okay, I know why. It's a very simple script, as you can see. I restart it. It's a local script so that I don't need to run Apache on this machine. It's very convenient when you want to deploy this on a machine which is not yours. See, it didn't visibly stopped. Okay. Here, back to this application. Okay, so you get the concept. This is a window machine. Okay, Oracle data in HTML format. Okay. You can browse the entire database this way, still the same way the data are given in the same formalization. If you want to see, yes, this is a Linux box. Okay, we are talking about communication between machines. I have opened, I reopen a connection to my server. Okay, and what do we see here? Of course, it displays only the Linux related script. Let's say all the Linux sockets. And here we might have an SSH connection somewhere. Yes, here. Okay, SSH. What is it? It is this connection. Okay. Okay. Well, we could. The demonstration could last literally 4 hours. Okay, I hope that you found that interesting. It's an open source tool, and it's extremely easy to add extra scripts for your own needs. It's literally with 20 or 30 lines of Python, you can add your own kind of object, your own scripts, your own methods of investigation. And it's an open source tool, so it's extremely open to any form of collaboration. So thank you. If you have any questions.
So you talked about using inference for this tool. What are you hoping to use it for? Is it to drive the UI or drive some of the analysis or both?
No, not to drive the UI. Why not? What I have in mind, specifically is to very simple example. You can, I don't go into the details, but when you can add several kind of data here, okay? Okay, you see I'm accumulating different scripts, okay? And this one, and for example, the dbus. Anything, okay? What do we see here? Okay, we see the list of links, okay, that we have added here, okay? We have entered we are displaying the Linux sockets, the users, okay? There are only 2 users because it's a bit private, okay? The debuses, okay? And it's merged, okay? We can display that in SVG, which is nice to show that to management board, for example. But this query, you can rerun it automatically, okay? If you are responsible of a machine, and if you say, okay, I want to see the processes, and in these processes, I want to see the Oracle connection, okay, from this machine, okay, you can have the result in HTML, okay, that's the same output, okay, and then in RVG, okay, that's the same result, okay, and if you rerun the query, okay, it's recalculated, okay. So if you use this data and if you have a bit of code which looks for specific patterns, okay, for example, an application which crashes, okay, or a session connected to Oracle for more than 2 hours, okay, and at the same time, you display the virtual memory used by a process, okay? It's not difficult to load this data, okay? Because this very cryptic stuff is a very simple encoding, base64 encoding of several queries, of the several URLs, okay? So you can use it very easily. It's encoded, otherwise it doesn't work in a CGI, okay? You can put some intelligence to look for specific events, okay? For example, you might be interested by this, okay? Not only for security, but you want to understand the behavior of an application, of several applications, because you are merging data coming from X machines. And all of these machines might not need Survol agent running onto them. I show you why. Okay, let's go back to my PC, to this very old machine. I'm a bit ashamed, sorry for that, but I can display here. Okay, here's the WEM. Gosh. System get system. No. Okay. Here I can see the WBM agents. Okay, that I know of. Okay, if it's nice, they will be displayed. Oh no, that's strange. Okay, normally it works. I tested it. Okay. Okay. Anyway, normally it works. I'm really sorry of that. That's very strange. Okay, you can make the demonstration. You can access WBM agent from a machine. Okay, you can interrogate a machine even if there is no Survol agent running onto it. Okay, there are several ways to do that. You can use WMI. You can use W.
The Linux version.
Yeah.
I think
Yeah, I don't know why. Okay, there's an issue. Maybe security issue. Okay, Yeah,
So
maybe.
there are already like standards that work on the network.
So, okay. So it's very strange that it doesn't work on two machines simultaneously. I suspect that, okay, maybe security
So
stuff.
Windows, I guess, has some remote investigation already.
Yes, yes, yes,
Linux
yes.
is the same thing.
Yes, yes, yes.
Okay.
So you can use WMI to interrogate another machine, even if there is no agent on it.
So you're basically looking to create some preset
Some
list of rules, some sort of set of rules, and then you could maybe highlight processes or
Yeah, yeah.
Okay.
And can you write annotations on this, for example? Because I'm just thinking about some examples. Remember, in the banks I worked, so you have thousands of systems, and you have a lot of forgotten software that runs on it, and then, okay, you will see the process name and everything, but you will have no idea what is this. So, and you may want to write something, or even to try to find an owner of it, and even write, I don't know, that who's the owner of that, who manages that, or who was managing.
You're absolutely right. I wanted to use Jupyter for that, because in Jupyter you can mix calls to Python and written text.
Oh, that's good. So they stay linked together.
Yes. Yes, it's starting to work. It's not difficult. You just need to load the URL and add your stuff and sell it as a consultant. For example, you can prove that during one day you've investigated an application and you have understood this, okay?
Yeah.
And it shows a query which shows a result, and you can give it to someone else.
I was
Yes.
thinking about in the ITIL, like point of view is like, let's say there's a new IT director and it comes there's a whole
Yes.
mess everywhere.
Yeah.
And,
Yeah, exactly.
and start to
Yeah.
identify what is what.
Absolutely, yeah, absolutely. And
So there was also Sparkle on your list of improvements. So you're thinking of building more of a query tool
yes,
as opposed to
yeah.
just the manual.
Yeah, I would like to do that. Yeah, there's another kind of display still for presentations in SVG Tech. You can print that. It's more convenient.
It scales better, I guess.
Yeah. Otherwise, D3 is not. It's not very convenient. You cannot do. Still, you can.
Browser.
Yeah. You can print that and you can write on it, and it's visible. It's another kind of output. And back to what you said. Yes, SparkQL would be fantastic. So many things to do.
What does it do? Sorry, Sparkle. What is
It's a query language.
this? Yeah. Query.
Query language to query linked
Peter,
data.
yeah.
That's good, thanks. Yeah, so that's basically, so for example, you can say, okay, find me these nodes or data in a graph that matches
In the graph.
certain pattern. So in all of this is a sort of massive graph. So if you,
Yeah.
if you look at the
Okay, you
System,
can
yeah.
use
System
any
tracking.
level, for example, in
Yeah.
the graph and identify some nodes that follow each other with certain patterns and something like this. Okay.
And
you can kind of build the rules actually. So rather than putting an inference and rule engine, you can kind of do that in
Yeah.
Sparkle more or less.
And back to RDF, these are typical examples of triples, okay, where you have the subject, the predicate, and the object, okay, and all of them are URIs, which is very convenient because as they are URIs, you can click on them and you can see what's on the other side, okay, and of course you have the same script, of course there's no process connected to it, circuit information maybe, yeah, a bit of information, but you still have the same interface, but it's more static, okay, it's different, but you can print them. Okay, but still it absolutely stick to the RDF logic, okay? But the ontology is WMI, which is a most ordinary description of data ever. So nothing new, but simply it articulates well.
So you were saying the only difficult thing is the Windows WMI libraries for.
I think it's slow. It is slow, okay? And you can only The design of the retrieval of data is horrible because you can only display one object or all the objects of one class, which means that if you want to get sim data file, okay, it takes hours, okay. So it's not, and you can only retrieve one type of object. Whereas with our scripts here, you retrieve a set of RDF data thanks to RDF.
Okay, yeah.